Today's lesson is on significant figures. This is something that we are going to use throughout the whole rest of the year as we focus on more of the mathematical concepts of chemistry. Significant figures are widely used in both the classroom and in industry when it comes to chemistry and physics because they really help us to understand what is truly being measured. So, what are significant figures? Well, they include every number that may be measured directly with a measuring tool, plus one more estimated number. Let's look at some examples. Here's a standard ruler that you would use. On one side it has inches, but we don't use inches when we're in chemistry class. We're going to use the metric side. Each of the itty-bitty lines in between is a millimeter, but these larger sections, 1, 2, 3, 4, etc., are centimeters. So we're going to measure to the nearest hundredth of a centimeter. I can measure directly between an 8 and a 9 because my arrow here comes after the 8 and yet it comes before the 9. I can safely say that my number is going to start with an 8. I can also look at the lines between the 8 and the 9. In any metric ruler, you're going to always have divisions of 10 because metrics are based on divisions of 10. If I count between the 8 and the 9, there are 10 sections. So from the 8, I can count 1, 2, and it's not quite to the 3. Therefore, my measurement is going to be 8.2, but almost to the 3, so I might say 8.27 or 8.28. That last number, the 7 or the 8, is what's called an estimated number. Remember, significant figures include every number that may be measured directly plus one more estimated number. So I can definitely say 8.2, and then I can estimate. Perhaps it's a 7 afterwards. That's an estimation, so your number might be a little different than mine, but we're definitely going to be the same on the 8.2, and we should be close on that estimated number. Another example down here, this arrow, what we can see here is it's definitely between the 26 and the 27, so we're going to start with a 2-6 points. Well, if I count over 1, 2, 3, 4, 5, 6, 7 definite lines, and it looks like it's right in between. So maybe I would say 26.75. Again, I can see the 26.7 directly, and I'm estimating one more value. And those are all significant numbers. So why does it become important? When observing the work of other scientific researchers, we can know how accurately they have measured. A misunderstanding of how accurate measurements are could lead to really bad calculations. So we always want to know how many significant figures we're dealing with when we're looking at other people's work. Before learning how to make calculations and round your answers with the right number of significant figures, you first have to be able to determine the amount of significant figures that are contained in a measurement. There are 5 rules that govern which figures are significant. When you're looking at a number, all non-zero numbers are significant. For example, in the measurement 1234, these are all non-zero numbers, so all 4 numbers are significant. So if I asked you how many significant figures are in 1234, you should be able to tell me that that's 4 significant figures. Second rule, zeros between significant figures are significant. Sometimes I refer to this as the sandwich rule because those zeros are sandwiched in between significant figures. An example would be 102. The 1 and 2 are both significant because of rule 1, that all non-zero numbers are significant. The 0 is going to be significant also because it's sandwiched in between the 1 and the 2. Therefore, in the number 102, there are 3 sigfigs, or significant figures. Third rule, if there is no decimal, zeros at the end of a measurement are not significant. So in this big number of 50 million, the 5 is the only significant figure. Remember that when we're looking at significant figures, that we have all of the numbers that could be measured directly plus one more estimated number. If there's only one more significant figure, or one total, that means that that must be an estimated digit. This is not something that we would want to rely on while doing some serious chemical calculations. The fourth rule is about measurements at the end, like the third rule, but it is if there is a decimal. When a decimal is present, the zeros at the end of the measurement are significant. For example, if we have the same number as above, but with a decimal after the 5, now all of those zeros are significant. Now there are 8 significant figures. We know this because of the decimal place. In fact, if we really measured that 50 million and knew that all of those numbers were significant, we wouldn't represent it like this up under Rule 3. We would represent it right here as 5.0000000 times 10 to the 7th power. We're still showing the place value by the times 10 to the 7th power that it's really 50 million, not just 5, but when we put those zeros after the decimal place, we're showing those zeros have indeed been measured, and only that last zero is an estimation. The final rule is on zeros at the beginning of a measurement, and they are not significant. These are only holding a place value. 0.000005, only the 5 is significant. So there would only be one significant figure in this measurement. Let's do some practice. Number 1, 123 meters. How many significant figures is this? Well, you should have said 3, because these are all non-zero numbers, so they are all significant. What about number 2? 0.124. Well, we know that the 1, the 2, and the 4 all count. How about the 0? Well, if we go back to Rule 5, 0 is at the beginning of the number, so no, the 0 doesn't count. There are 3 significant figures. How many significant figures are in example 3? Well, remember the sandwich rule? The 4, 5, 6 are all significant because they're non-zero numbers. The 2 zeros are sandwiched in between the 4 and the 5 and the 5 and the 6. Therefore, all 5 numbers are significant. How about number 4? Well, the times 10 to the 4th is just changing my place value. What's key here is if I look at the 9.8000, those zeros are all following a decimal, but they're not in the front like they were in number 2. So since they're both after a decimal and at the end instead of the beginning, they're all going to count. So number 4 has 5 significant figures. So now that you're starting to get a feel for significant figures, we're going to do a sigfig lab in class tomorrow. You're going to measure items to the nearest hundredth of a centimeter to get started. If you don't feel that you know how to do this, go back and review the beginning of this video. I showed you some examples of some rulers, and you should be ready to do that when you come in tomorrow.